Good evening, students. Am I audible and visible to all of you?
Yes, ma'am.
Okay. So should we start? What has happened to the video of everyone? Ananya, Ritika, Shweta? Is my screen visible to all of you?
Yes, ma'am.
Okay. See, in the last class, we were discussing or we started discussing the periodic classification of elements. And if I remember correctly, we were doing one question, which I just said that we'll be taking up in the next class. Do you remember this question? Have you tried to solve this question? If your video is a problem, no issues, but you can at least speak.
Yes, ma'am. I actually tried it.
Okay, I will quickly show you the solution or tell you how to do it, because I believe this question is not very popular in your books, but it is usually asked in various exams. So according to this question, we are given a 10 ml solution of sodium chloride, which has potassium chloride, that is KCl, as impurity, right? Now you have a solution, you are evaporating it. When you evaporate, you get a certain solid at the bottom, right? So when you heat it or evaporate it, what do you get? You get 1.865 grams of silver chloride, right? And they want you to find out the quantity of sodium chloride present in 10 ml of the solution. So for this, what we have to do, first of all, we will list what is given to us. As you can see, we are given that the solution contains that, so this is what is given. It is given as a mixture of sodium chloride and potassium chloride. Its volume is 10 ml and the mass of sodium chloride and potassium chloride is 0.93. Mass of silver chloride formed is 1.865. Now, what we have to do for solving such question? We have to assume the total mass of sodium chloride and potassium chloride. So we have just assumed in the next step that mass of sodium chloride is A grams as listed here, and that of potassium chloride is B, right? Now, next step is we write the chemical reaction taking place. So that reaction is that silver nitrate is reacting with sodium chloride to give you NaNO3 and AgCl. Similarly, we can write the reaction of silver nitrate with KCl. That is potassium chloride. You will get potassium nitrate and silver chloride. Then what we will do in the next step, we will calculate the molecular masses of sodium chloride, potassium chloride, and silver chloride. This you have to remember that molecular mass of sodium is 23. I believe by this time you must have remembered this one. Potassium is 39. Silver may be an information for you. Remember the atomic mass of silver is 108. So what you have to do, all of them are chlorides. So for chlorine, you will be taking 35.5 to find the molecular mass of sodium chloride, sodium chloride, potassium chloride, and silver chloride. Now, since we have to solve it on the basis of stoichiometry, that is, it is involving the chemical reaction as well as the mole concept. So according to the balanced chemical equation, you can see that 58.5 grams of sodium chloride gives 143.5 grams of potassium chloride. That silver chloride that we have already learned in the previous classes, that how we are going to equate the molecular mass mole number with the equation things. Is it clear to all of you, Ritika, Shweta and Ananya?
Yes, ma'am.
Yes, ma'am.
Okay.
Yes, ma'am.
So from this point, it has to be pretty easy that 58.5 grams of sodium chloride gives 143.5. Therefore, how much A will produce? So this is one thing you will get. Same equation, you will be writing it for potassium chloride. That 74.5 grams of potassium chloride gives us this much. So how much B grams will produce, right? But in the question, we are given that 1.865 grams of silver chloride is produced. So that means if I do the sum of both the equations producing silver chloride, that should be equal to 1.865. After that, you have two equations, equation 1 and equation 2. You can solve them. I can just suggest one way of solving the equations, although I understand you people must be more efficient than me in solving them. As we say, A plus B is equal to 0.93. So therefore, A will be equal to 0.93 minus B. Now substitute the value of this A in equation 2 and get the answer. Is it clear?
Yes, ma'am.
What about Ritika and Shweta?
Yes, ma'am.
Okay. Now you should try the questions from the various books, right? This type of a question can be expected in any type of a competitive exams, maybe in the school exam also, because since you have done this question, you should be able to at least approach them. One of the questions which I can suggest to do is that where you are asked to find a percentage purity of a compound, right? And still, if you have any query into them, in any such question, please get back to me, or you can post your inquiries at the given number and we will sort them off quickly. So can anybody tell me? See, let's begin with Ritika. Have you understood the Dubinier's triads?
Yes, ma'am. Somewhat I understood it a bit.
Okay. What about Ananya?
Yes, ma'am, I can understand.
Okay. What about Shweta? Shweta, I cannot hear any reply from you. See, earlier when we have, or the scientists have little means, the number of elements known to them were also less. So what they did was they studied each one of them closely and then started finding out similarities in them. Dubinier was one of the such scientists. He noticed when the elements having similar properties, as you can see, the first example which he took was of lithium, sodium, and potassium. As we progress in this chapter, I will request all of you to keep on remembering the names and symbol, the association between them, which is very important for you, right? Because as we progress, we will be using many such names and trends will be asked. So if you do not know the number and name and the symbol relationship, you won't be able to recognize the element and then hence not able to solve the problem. So talking about Dubinier's law of triads, tri means three. That we know very well, right? Triads in any case is going to refer to 3. So what he observed was that when he arranged the elements named as lithium, sodium, or potassium, and these 3 elements, what he noticed that all 3 of them are metals, right? Then he noticed, then they react with water, they form alkali. Can anybody define alkali for me? What is an alkali? This we did in class 10.
It is a chemical that dissolves in water and combines with acid to form salts.
Partly correct. See, I'll make some correction into what you said. See, alkali is not a, of course, it's a chemical, it's a broader group. Precisely, the definition for alkali is, it is a water soluble base, right?
Ma'am.
Whenever you come across any such definition or a word and I miss it by chance, please feel free to ask me. Because there was a certain syllabus which was there in class 11 previously, then it got deleted. So although I try my best to include in when I'm teaching, but at times I may also miss it, right? So please note down, because we will be taking up this chapter, acid, bases, and salts, in the name of equilibrium. There it will be of very useful. So what is a base? We always define it as water soluble, rather what is an alkali? Base is defined as something which produces OH minus ion. And if it is water soluble, then it is called as alkali, right? So what do we say? Water soluble bases are called as alkali. A special name to a category of a base, right? Acid is a substance which Ritika correctly said that acid will produce H plus and bases will produce OH minus. That is the classical or the basic definition as of now, right? But water soluble bases will be called as alkali. So that means what we are trying to say, that lithium, sodium, and potassium, they react with water and to form such a base which when dissolved in water becomes soluble and they liberate hydrogen gas. All of them have valency 1. I think that makes sense to all of you, right? So when he noticed the chemical properties are similar, so he decided to put them in the group of 3, arranged them in the increasing atomic mass. Atomic mass of lithium is 6.9, or we can take it as even as 7. Sodium, it is 23. Potassium, it is 39. So what will be the sum quickly? 7 plus 23 plus 39. What we are expecting to get? Any answer? Is it coming to closer to 23 or not? Sorry. We have to add 7 plus 39 and divide it by 2. So this will be 46 by 2, which is 23. So this is what Daubigny said, that when he arranged the elements showing the similar chemical properties in the increasing order of their atomic masses, he noticed that the atomic mass of the middle element, that is sodium in this case, is the same as the arithmetic mean of the atomic masses of other 2 elements. Is it clear to someone? I think Ananya said it is slightly clear. Is it clear to you, Ananya, now?
Ma'am, I said it was clear.
I didn't get you.
No, ma'am, I said it was clear. I
Okay,
understood.
I don't, then Ritika, you said it is not clear.
Yes, ma'am, I said it.
Okay, is it clear now?
Yes, ma'am.
Okay. So this is what how I explained in the last class, that assumingly the atomic masses of element A and C are X and Y. So atomic mass of B will be X plus Y divided by 2. Now, this is another example where he took calcium, strontium, and barium. These are the elements of group 2 of modern periodic table. We'll take up modern periodic table in the following classes, or maybe we'll start it today itself, right? So what he observed, that as for the previous set, he said they all of them are metals, their valency was 2, and their oxides are alkaline in nature. Can somebody define what is an oxide? You will come across two terms, oxide and hydroxide. Can someone define these two terms? What is a chloride? I believe that should be easier for you. In class 10th, you must have heard about or read about the families of salts. Was it there in syllabus or not, Ritika?
Yes, ma'am.
Okay. So in the families of salts, what we studied or what we came to know was that they have either similar cation or similar anion. Talking on the same lines, I can say that sodium chloride, potassium chloride, silver chloride, magnesium chloride, all of them, and including say iron chloride, they are the family of chlorides. They have the same anions. So that means what will be a chloride? A chloride will be a compound having X minus. I believe you know what is X. X can be anything like fluorine, chlorine, bromine, and iodine. Please note down this thing. We'll be talking about what are halogens. You may not be able to understand it clearly. I'm again repeating because these terms will be very frequently used in modern periodic table. So X is usually used to represent halogens. What are halogens? Halogen can be fluorine, chlorine, bromine, or iodine. Now, understanding what is an hydroxide. Hydroxide will be a compound or a salt in which we have OH minus ion as the anion. Hydroxide ion is OH minus. And similarly, oxide will be O2 minus, right?
Yes,
You
ma'am.
might have heard about the compound magnesium oxide when you were doing the class 10th chapter, chemical reactions and equations. Can somebody quickly tell me the formula of magnesium oxide?
MgO.
Correct. What about sodium oxide?
Na2O.
Very correct. Although there was less of a confidence, that is the reason I thought I will just give you. See, you have to have the anions intact. Anion if you know the formula of anion, it will be easier for you to write the formula. I know you know, it's just a recap or just building up the concept. So I think this point is clear that calcium, strontium, and barium, as you can see on the screen, that atomic mass of strontium, this element, is arithmetic mean of atomic mass of calcium and barium, right? Calcium, instead of 40.1, we can always take it as 40. For barium, we can do it by using 137. 88.7 and 87.6 are approximately same. But there came the issue or the concern. He observed that nitrogen, phosphorus, and arsenic, as displayed here, show similarity in properties. Let us say all of them have same number of electrons in the valence shell. That is, nitrogen has 5, phosphorus has 5, arsenic also has 5 electrons in the valence shell. But if he arranged them in the increasing order of their atomic masses like this, nitrogen followed by phosphorus followed by arsenic, atomic mass of nitrogen is 14, that of arsenic is 74.9. But the actual atomic mass of phosphorus is 31 and that of arsenic is 44.45, right? So that means they are no more closer. They are not almost similar. There is a gap of 15 units. So that means it is not an example of Daubigny's triad. With this, we can conclude that all the elements which were known at that time could not be placed in the triads form. He could find only these three. I will appreciate if you can know, although it is from your NCERT books only. You may be having it by the name of SCERT, I believe. The table number may be different, but in the chapter you will find it there. These are the only three legitimate, that is the possible Daubigny triads, as he said at that time. Rest of the elements do not follow this law. Is it clear?
Yes,
Because
ma'am.
in MCQ, okay, because in the MCQ you may get, which is not a Daubigny triad. So instead of calculating, see again, last time when we discussed the paper, I told you that you must have a shorter way to answer a MCQ question. In MCQ, as a teacher, I don't expect you to do the calculation. That is how I frame the question. I expect you to be smart enough to come to the correct answer. So if you know the three triads and you remember that triad means three, an example. Sorry. Examples are also three. So whatever else is given is just for confusing you, right? So that was the reason for the failure of Daubigny's triad, that only few triads could be identified. Therefore, it was not very useful because they cannot classify all the elements. After that, we started learning about the Newland's law of octave. Since in the last class we did them in a hurry, so I thought I'll just give you a recap. The basic thing we have to learn is that Newlands was a musician by heart, so he found the similarity in the property of the elements and the musical notes, like sa, re, ga, ma, pa, dha, ni, and again the sa will come. So what he did was that he arranged the elements in the increasing atomic mass number, and then he noticed that every 8th element is similar to the first element in the property. Therefore, sometimes it is referred as Newland's law of octaves also. And this number is critical or important for us, that at that time only 56 elements were known. Sometimes there is a confusion, or you may be asked to do a match the column question. Today we know, you can write it down at one place. Today we know about 118 elements. Previously, at the time of Mendeleev, we will just be doing that. Mendeleev knew about the 63 elements and Newlands knew about the 56 elements only. So crisscross matching has to be there, right? 2 years ago, we knew only about the not 118, 114. If somebody asked me that how many elements were known, you have to put a year there, right? That is 2 years ago, that is 2020. We knew about the existence of only 114 elements. Comes 2022, we know the existence of 118. This Newlands knew about 56 and Mendeleev knew about 63 elements, right? But like any other periodic table, this also has, or the classification, it also had certain issues. Here are the symbols just for a recap that what all elements he could classify as his octave, right? He could put only these many elements, as you can see on your screen, that hydrogen, fluorine, lithium, sodium, potassium, that beryllium, magnesium, calcium, boron, aluminium, carbon, silicon, nitrogen, phosphorus, oxygen, sulfur. Calcium atomic number only 20, right? But he atomic number 20, atomic mass 40, that we just did. So although 56 were there, he could successfully classify only 40 elements of that time, right? Now, these are the features or what can be expected from Newlands periodic table. If you look at this carefully, he has somehow managed to adjust the 56 elements. But the main issues are that if you notice that certain elements are grouped together, like you can see cobalt and nickel. Do you know the symbol of cobalt? Anybody? This is cobalt. This is cobalt and this is nickel, right? And then this is cerium and lawrencium. Just in order to accommodate or explain few things, he kept certain elements together, right? That was one of its drawbacks. And then two elements with different chemical properties were kept in the same text box. Like the properties of cerium and lanthanum do not match, but they are kept in the same box, right? So these are the certain drawbacks. And the last one is that he has, that is not that important, but what there are certain elements which do not have similar properties are placed together, and the contrary to it is also true for this periodic table, right? Any doubts in this section?
No.
Okay, see, maybe we will come, it's just a brief introduction, I'll tell you, because unless we learn, see, like inert gases, I have purposely, like iron and cobalt, I have not dealt that point in detail purposely, because when we deal with modern periodic table, these elements are explained there. Then if you come back to Newlands, then they will become clearer to you. Inert gases, they are not explained here. Maybe you are able to understand even at this point because you are taught in your school itself. Is it clear to all of you? Please don't understand that certain things are not clear to you. See, we are doing a gradual learning of the periodic table. Is it making sense to all of you?
Yes, ma'am.
Okay, we will definitely come back to it. Don't worry about it. Now we will do quickly what is Mendeleev's periodic table. Is it covered in your school or not? Ritika,
They
have you
haven't
been?
started this lesson in the school.
They haven't started. What about Ananya?
No, mom, we haven't taught this chapter yet. They started with the second chapter.
Okay. Shweta?
No, they haven't taught this.
Okay. So because that helps me in putting my pace itself. If you are understanding something for the first time, I must teach you in that spirit only. There was a scientist called as Mendeleev. He was from Germany. At his time, 63 elements were known. And what he did was, whatever element was known at that time, he made a flashcard. Like we play cards. You might have seen that cards which maybe elderly people play, or you must have come across. They have number and the image 1 to 14, different color, spade and diamond and all those things. What he did was that he prepared one chart for each of the element known at that point. So let's say it was hydrogen. He noticed what is the formula of its oxide? What is the formula of its hydroxide? Maybe a question comes in your mind, why oxide and hydroxide? Why not chlorides and sulfates and all those compounds of other anion family? Honestly speaking, the reason is very generic and obvious. Oxygen is in abundance. Whatever we are doing, whatever we are teaching, studying, whatever we are doing in the atmosphere of oxygen itself. So the first choice they have to react with anything is oxygen in the form of oxide. And our Earth is known as blue planet. That means we have abundance of water. So the other thing, if the element is soluble in water, what it will do? It will react with water and form the hydroxide. So, like if I ask you, what is the form of sweetener used at your home? I believe all of you are going to tell me sugar. Any other answer comes to your mind? What is the sweetener?
Jaggery.
Yeah, jaggery is one. Jaggery, honey, right? They can be used as sweeteners. Sometimes if somebody has some people at home suffering from diabetes, they might be using something stevia or something else like that. Similarly, when it comes to studying a compound, there can be, as I told you, sulfate, sulfide, sulfite, carbonate, bicarbonate, oxide, hydroxide, chloride, bromide, ion, iodide. Approximately 15 ions I have told you, right? So it's not possible humanly possible to any one of us to study all 50. First of all, prepare them and then study them. So whatever was available in abundance, he studied them. One of the questions which is asked from Mendeleev's periodic table is that why he studied oxides and hydroxide only. Logic at times is very simple because they were the only available compound, right? And when he has to do a comparative study, more importantly, all of them should be forming that compound, right? So, and that is the reason he picked up oxides and hydroxide. Whatever was known about them, their color, density, atomic mass, he pasted here on this chart, right? Similarly, he took another element. Let's say he took oxygen and write everything about it here. Like that, he made 63 cards of whatever information was available for a particular element at that particular time. Then he tried to arrange them in an order, right? Like we hang our clothes on what we call it as a strong wire, 1, 2, 3, 4, 5, 6. Then once it is done, we have another wire or a rope to put more clothes on it, right? Or we have a stand to dry up our clothes, that also has 2, 3 or a 4 rows. So similarly, he said, okay, I will arrange them in such a way that element with the similar properties comes after that. Maybe that if the formula of oxide is, let's say, R2O, R can be the symbol of any element. So all the elements having oxide formula as R2O were placed one after the other. That is how he made the rough structure of the periodic table, right? So it was his skills only which led him to get such a basic concept in a beautiful way. So what he did was that he arranged the elements in the increasing order of atomic mass. And then he understood that there is a periodicity. I believe you understand the meaning of periodicity. Like weather, we have these days we are having by and large. I'm not too sure about Chennai. Where I'm living in Delhi, I can say this is a rainy season. It will be followed by winter. Winter will be followed by summer, and then again the rainy. In between, spring and all those things will come. I believe such a thing happens at Chennai or not, Ritika?
Ma'am, we have summer, rainy, and winter season. Ma'am. It happens.
Okay. The cycle keeps on going, right? That is periodicity. Like sun rises every morning, say entire year, between say 5 to 7, 5 to 6, something like that. So that is every 24 hours the sun will rise approximately. Every say summer is a longer period, say summer is of 5 months, winter is of 2 months, something like that. So after every specific time interval, something is going to repeat. That is called as periodicity. So he noticed therefore the keyword here is periodicity. He noticed the periodicity in the properties of the elements. That is, the properties are repeated after a certain time interval. So what he gave on this basis, he gave his periodic law. What was that? According to his law, that physical and chemical properties of elements are the periodic function of their atomic masses. Right?
Yes, ma'am.
Okay. So please note down, it is important because when we will moving to modern periodic table, it will become the comparative statement. If you remember it in the same sense, it will be easier for you to grasp it for the modern periodic table also. The physical and chemical properties of elements are the periodic function of their atomic numbers. Sorry, atomic masses. Right? Moving on. This is how the Mendeleev's periodic table look like. I'll be explaining first that Mendeleev's periodic table, how many groups and what is a group and what is a period. The periodic table comprises of a grid sort of a thing. These are called as vertical columns, or they are known as groups. Remember, we'll be talking in terms of groups and periods every time now onwards. And the horizontal things. They are known as horizontal rows are known as columns. Is it clear to everyone now?
Yes,
What is a
ma'am.
group? What is a group and what is a period? So what Mendeleev did was that he arranged all the elements known at that time in the form of this table. And this is called as Mendeleev's periodic table, right? In Mendeleev's periodic table, the main thing which we have to focus is that, as you can see, that atomic number 44, he has put a question mark there. Can you see the question mark at 44?
Yes, ma'am.
He has put question mark at few places. That is, these were the elements which were not known at that particular time, right? They were not known to anyone, but he knew because he has arranged them systematically. Like sometimes when you solve a number grid like this, say suppose I write 5, 10, and then there is a blank, then I write 20, then I write 2 blanks, and then I write 35. You can predict what will come there. So since he placed boron and aluminium above 44, it can be predicted that this element's property should be similar to that of boron and aluminium. Later on, this is just a comparison. You need not remember this table. You just have to understand what he did was and how correct he was. That whatever elements were not known at that time, he put the word Eka before their names. So he predicted Eka aluminium, which is today known as gallium. Ga has the symbol is Ga, right? He predicted that Eka aluminium atomic mass or atomic weight would be around 68. When this element was discovered, it was found 69.72, pretty close. Similarly, density was also found to be close. Melting point, he said it is low. You must remember that low and high are very, very comparative terms. Comparative means that steam may be high temperature for someone as compared to room temperature. But if you are carrying out a chemical process at 500 degrees centigrade, that means the temperature of steam is less, right? So he said it will be comparatively low. He meant around room temperature. So that is approximately 30. He predicted the valency as 3 and it was found to be as 3. He predicted the formula to be as EA2O3. He predicted the symbol, or he gave the symbol to element as EA. So, and later on it was found that the formula of gallium oxide is Ga2O3. Can anybody tell me the formula of aluminium oxide?
Al2O3.
Correct. So that means aluminium and gallium belong to the same group, as we can see here, right? Boron, if you we will be doing the modern periodic table: boron, aluminium, gallium, indium, thallium. So that means his predictions were pretty accurate. So the portion written in the blue has to be, I have no other choice but to say that has to be crammed, remembered thoroughly. One of the most often asked from question in any form of exam is this one: what he predicted and what it is now known as. That this element, Eka boron, is now known as scandium, atomic number 21. Aluminium, Eka aluminium is now known as gallium, and Eka silicon is known as germanium, right? They are very often asked. Their older name given to them was Mendeleev is this, so tell me the newer name, right? So have you noted down?
Just a minute, ma'am.
Okay, I'm waiting. Please do it. Done?
Yes, ma'am.
Okay. Everybody done? Not only Ritika. I'm asking to Ananya and Shweta also.
Yes, ma'am. Yes, ma'am.
Okay. See, some of the books, I'll just share the NCERT also with you. I don't find any other logical reason in telling you that how many groups and periods are there in Mendeleev's periodic table. I'm telling you in brief, in case your school teaches you in much more detail, then please put your feedback in the number provided to you. I'll explain it to a greater extent. Although whatever feedback I have from various schools, I am teaching you on a slightly more informative way. I'll just do the quick, teach you the quick numbering of the groups and periods. As you can see, this is Mendeleev's periodic table, and groups are numbered as you can see, 1, 2, 3, 4, 5, 6, 7, and 8. Then you can see every group is followed by a certain period. Now the period numbering is not very clear to anyone. What he has done, that period he has divided into two subgroups, period, the A and B. As you can see, this is lithium is subgroup A, sodium is subgroup B, right? Beryllium subgroup 2, magnesium subgroup 24. Is it making sense to you or not?
Ma'am, can you explain this from the first again?
Okay. Numbering of groups is clear.
Yes, ma'am.
That is, they are numbered as 1 to 8. Now, the numbers which are written on this part of the periodic table, these numbers, they have a lot of confusion. Either you take this picture or you take this picture, right? He says the number of periods is only 2. But if you see the numbering, if you see even the original picture of modern periodic, Mendeleev's periodic table, you will see them like this. So then there is a lot of confusion. The best way to explain is that whatever is written in one box, right? This one, since it is the first, it is considered as period 1. This entire one is period 1. I say that period 1 is divided into 2, A and B part. Hydrogen, you can see, is a unique thing. It is the only place in the entire periodic table which has 3 elements. Apart from this, you can see this 4 and 5, whatever they have written as 4 and 5 in one box, that is considered as, this is our period 2. Similarly, 6 and 7 will completely make it as period 3. Is it making sense now to all of you?
Yes, ma'am.
Okay. This is period 3 for us. This is period 4 for us. This is 5. And this is 6. Right? Then, this is one of the defects of Mendeleev's periodic table, that hydrogen is not given a satisfactory position. Only for the group numbers we can say it has got 8 groups. Another confusion with Mendeleev comes that you have a Mendeleev's periodic table. There were certain dedicated students of Mendeleev who, after his death, carried out his work, and then they added few more groups, few more elements into it. Therefore, I say, remember for Mendeleev periodic table, only 63. In some cases, you may find 87, 85, any number can be there. But remember what they have said in prefix. That means whenever they will refer to Mendeleev periodic table, it has to be only 63. But if somebody says modern Mendeleev periodic table, it can be up to 87, any number. You can imagine that his followers, his students, his disciples were working on it. As and when a new element was discovered by other scientists, they give a respective position in their periodic table. So again, this is a very important point for solving MCQ. So therefore, I'm repeating it again, that for Mendeleev periodic table, remember 63 as the only number of elements known to Mendeleev, right? So as you can see, there are all the periods rather, that you can see there are 2, A and B, 2. Here the blanks, there are no blanks and nothing is added. That means no elements was known at that time, right? Here you can see in group 8, he has placed 3 elements, right? Iron,
Yes,
cobalt,
ma'am.
nickel, ruthium, rhodium, and palladium, osmium, iridium, and platinum. So this is just the description of Mendeleev periodic table. And I'm expecting only the question on the Eka aluminum, Eka boron, and Eka silicon. That's all. There should be no question. If there are questions, they have to be comparative to modern periodic table, which can be well understood only when we know the structure of Mendeleev periodic table, and then we can build our concepts of modern periodic table. Now, as you can see, there are why now we have to understand why Mendeleev's periodic table failed. Mendeleev's periodic law. If anybody can read it out or even explain to me what is Mendeleev's periodic law. Anyone, quickly? Ritika, please go back to your copy. We have just done it or not? I think I wrote it somewhere. Yeah, here I found it. Physical and chemical properties of elements are the periodic function of their atomic masses. Now we know that have we discussed this term sometimes? Isotopes. Shweta, can you define isotopes for me?
Yes, ma'am.
What are isotopes?
They have the same number of protons but different number of neutrons.
Correct. Now, talking about hydrogen has got three isotopes: protium, deuterium, and tritium. 1, 1, 2, and 1, 3. Atomic mass of this hydrogen atom, that is protium, is 1. This one is 2, and this one is 3. Now, when Mendeleev was preparing his periodic table, he said elements are arranged in increasing order of atomic masses. That means in his periodic table, hydrogen should occupy 3 places: one with atomic mass 1, other with atomic mass 2, another with atomic mass 3, then there should be helium with atomic mass 4. Isn't it? Is it making sense, Ananya?
Yes, ma'am.
Ritika, you and Shweta?
Yes, ma'am.
Oh. So this is one of the defects of Mendeleev's periodic table, right? The number one, I told you, position of hydrogen is not correct. Now the second point, isotopes are not given separate places. We should have hydrogen at 3 places. We know the oxygen has 2 isotopes at least, O16 and O18. O17 is also there. Chlorine has 17, chlorine has 35 and 37. So the periodic table should have been very, very, very big, right? So that means the second point which he missed was that isotopes are not given separate positions, right? Is it clear? Now, okay. Now, can you look at this? I think this periodic table is large enough for you to find out where the law is not, the increasing order law is not followed. Can you find any position in which the element with atomic mass higher is placed later? Found anyone?
Ma'am, not sure, ma'am.
Not sure. Okay. Take 2 more minutes and find it out. Let's try to find it in this one, if we can. See, they have not mentioned in it deliberately, I believe. Neither in this form. I was also searching somewhere. See, between cobalt and nickel, they say atomic mass of cobalt is said to be 58.9. And nickel is 58.7. Right? So what should come first, cobalt or nickel?
Nickel.
Nickel. But what he has done, look at this point. I was wondering how all of us eyes can fail. They have put an incorrect value in this table. Although I have taken the image from the site where Mendeleev's original work is kept. They should make a correction here. But that gave us a good exercise. So between cobalt and nickel, is it clear that 58.7 nickel should have been placed before cobalt? Is it clear or not to everyone? Shweta and Ananya, I can hear it from Ritika, but not from Ananya
Yes.
and
Yes, ma'am.
so please note as it as the third point that he did not obey his own law, right? At certain places where he placed the element with the higher atomic mass after the element with the lower atom, he reversed the order of increasing atomic masses. Example, please write down as cobalt and nickel. We spent 2-3 minutes more on it because it is again a question asked in the exam. Have you all noted down?
Yes, ma'am.
Okay. Now moving to the next point, that some elements with dissimilar properties are kept together. If I look at this group, potassium and copper, we know copper is highly unreactive. That is the reason it is used in making the coins, the ornaments, etc. But sodium and potassium, they are highly reactive. Potassium is stored in oil, right? Because it is very reactive. So how can you place the two almost oppositely charactered elements together? That was another point at which Mendeleev's periodic table failed. So if somebody asks me, let it be a 2-mark or a 3-mark or a 4-mark question, if they ask you to write the demerits of Mendeleev's periodic table, the first one is that the position of hydrogen is not satisfactory. Number 2, isotopes are not assigned separate positions. Number 3, at some places, the order of increasing atomic masses is reversed. Number 4, in certain periods, the elements with the opposite or a different properties are kept together. Is it clear?
Yes, ma'am.
Okay, now let's quickly do one multiple choice question. If I give you a MCQ saying Mendeleev's periodic table is based on option 1, increasing order of atomic mass. Number 2, similarity in property. Number 3, both A and B. Right? I'm looking for a correct answer. What is your take, Shweta? Any answer, Ritika?
Ma'am, increase in order of atomic mass.
Okay. What is your answer, Ananya? And Shweta, I'm waiting for your answer also. Yeah, Ananya, I couldn't hear. Please repeat.
1 second, I'm in the last one.
You are saying the last option. Shweta, what is your option?
No, 1 second, I'm still solving. I'm in the last part.
Okay, you are saying the.
Mom, I said I'm still solving it. I'm in the last part.
Okay. Waiting. See, don't ever get confused by the spelling of Mendeleev. Some people write Mendeleev V and some people write F. Both the spellings are correct. Done the question or not?
Mom, I'm getting option B, A.
A. Okay. If I put, I will go with the similarity in property. See, he has given you the exception. That was the reason I was teaching you the exception between cobalt and nickel. Correct. He gave the law of increasing atomic masses. But ultimately what he did was, he did not follow his own law. That means, if I word my question as Mendeleev's periodic table is based on, definitely the answer is 1. It is based on, right, increasing order of atomic masses. But therefore, the first was, if you read the question carefully, it has to be the option 1. But if you read manually, if I change the stem of the question, if I rephrase it as that, instead of Mendeleev's periodic table gave more importance to, right? Then the correct answer becomes similarity in properties. In any case, this will never be an option. It is a very common mistake which we commit. Is it clear that for Mendeleev, that we have to read the question paper very carefully? If the question is asking for the basis of Mendeleev's periodic table, it is either atomic mass or increasing order of atomic mass, whichever is given there. But if it is saying that Mendeleev paid more attention to, or his periodic classification is based on what he gave while classifying elements. He paid more attention to, that was similarities in properties. The reason being, he himself overruled his own law, his own rule. Is it clear to all of you?
Yes, ma'am.
Okay, because this chapter you'll be finding it is bit theoretical as compared to our chapter number 1, which we did. That had so many numericals, and this one has a lot of theoretical things to understand. Right? Now, moving on to modern periodic table. I believe there will be no confusion if we start modern periodic table now. See, modern periodic table is based on modern periodic law. I just in between the class, I asked you to reiterate the Mendeleev periodic law. What we have to do here is we just simply have to replace one word. We said that physical and chemical properties. I will appreciate if all of you can remember this one. Physical and chemical properties of all elements are periodic function of their atomic numbers. Remember, I gave you almost the same statement when we talked about Mendeleev. In Mendeleev's periodic table, atomic numbers is replaced by atomic masses, right? So just remember one statement. If you are writing atomic numbers, it will be modern periodic law. And if you're writing atomic masses, it will be Mendeleev's periodic law. So for understanding modern periodic law, we have to be very clear about the electronic configuration of elements as taught in chapter 2. How many of you are very clear of writing the configuration in terms of SPDF and then converting into orbit configuration of 2, 8, 18, 32? I hope my question is clear. Ananya, you have raised your hand. Any issues?
No, ma'am, I raised it to tell that I know.
Okay,
right.
you know. Okay. What about Ritika and Shweta?
Yes.
I know it, ma'am.
Okay, let's take an example. I want a configuration in terms of 27 as SPDF. What have you written, Shweta?
1 second.
Okay.
From the electronic configuration, right?
Yeah.
I got 1s2,
Yeah.
2s2,
Yeah.
2p6,
Yeah.
3s2,
Yeah.
3p6,
Okay. Then
4s2,
hmm,
and 3d5.
3D 5.
Yes.
Okay. Ananya and Ritika, are you through with it?
Ma'am, I'm getting the same one, ma'am.
3D 5. I have asked for
3d6, ma'am. Sorry,
20.
3d6. Sorry.
Recheck your mathematics.
It's 3d7.
Ananya, what are you getting?
I'm getting 1s2, 2s2, 2p6, 3s2, 3p6, 4s2, and 3d7.
3D 7. The correct configuration should be 3D 7. Is it clear to everyone?
Yes, ma'am.
Yes, ma'am.
Now, if I ask you to convert it into 2, 8, 18 terms, will you be able to do it? Do you know how to do that?
Ma'am.
If you know, just do it. And if you are not, if you do not know, let me know. I will tell you how to do it. Got the answer or not, Ritika?
Ma'am, I don't know how to do this.
Okay. Anybody who knows it? Shweta, you know it? Let me tell you how to do it. Do you understand that the first orbit is split into only S subshell? Second orbit is split into S and P. The third is split in S, P, and D. And fourth or onwards, every orbit is split into S, P, D, and F orbital. Is it clear to all of you?
Yes, ma'am.
Okay. And quantum number similarly must be very clear to all of you. So when I have to convert the orbital configuration into orbit, the element with suffix, rather prefix as 1 is only one entry. So what I will do, the first orbit will have 2 electrons. For the second orbit, I can see that 2s2 and 2p6. So that means there will be total of 2 plus 6, 8 electrons in the second orbit. Coming to the third one, the third orbit has 3s, 3p, and 3d, right? What I have to do? I have to find their sum. So that will make it as 15, right? So third shell will have 15, and for fourth, I have only one entry, right? So the fourth shell will have only 2 electron. Now the question arises, why I have to make you do this? First of all, let me know if anyone is having any doubt in this concept.
No.
Okay. See, when we talk about modern periodic table, we have to assign given atomic number a particular position in the periodic table. For that, both of them are important to us. Sometimes some of the students write this configuration not like this. They write it as 3s2, 3p6, 3d7, 4s2, right? That is not the correct way of writing. Whenever we are solving a question related to modern periodic table, the position of element, it is important. We must write the configuration in the order the electrons are filled. As you can see, this is 27. And if I remember correctly, 27 is the atomic number of cobalt, CO. D7 means that the last electron or the last electron is entering into D subshell. That means it has to be found in the D block. I will roughly give you an idea of the blocks in the periodic table. Before that, let me share how the modern periodic table looked in 2018. You can see that the name says UUT at the bottom of the blue line, and I'm referring to UUT, UUP, UUS, and UUO. These elements, these are the names of the elements which were given to IUPAC rules, which we will be covering of course, in the next class. They were not given a official name by IUPAC. Whenever an element is discovered by the various scientists, they have to submit all the records which they have created to IUPAC. They assign and approve the element, only then they are known to us as a officially recognized elements. So in 2018, that UUT, UUP, UUS, and UUO were not known to us, but in 2019, in that IUPAC recognized their existence. Now you know them as niobium, flavomorium, livermorium, technetium, oganesson, right? So these elements were recognized by it. So the total number became 118. Now, the biggest thing which you must keep in mind, if you are referring to old NCERT, even new NCERT might not have changed. The sixth period, now you get sixth period, probably you will not be able to understand the last one in the this one. This particular set of this is the series, the seventh series or the seventh period. It was supposed to be incomplete because all elements were not discovered earlier, right? But now the periodic table is complete till seventh period. Even if the book says it is incomplete, please understand the book is having the data which was correct till year 2018 only, when these four elements were not discovered. Then whenever we teach the periodic classification or periodic table to students, we say that this is the first period, second period, third period, fourth, fifth, sixth, and seventh period. Period, I believe you understand the horizontal rows. The first period of modern periodic table, as you can see, has only two elements. That is it. The second period has 8, third has 8, they have 18, they have 18, these have 32, and this is incomplete, right? Because the four elements are unknown. That is how the periods are described in all the chemistry books for us. But now everyone has to understand that the seventh period is also complete now with the discovery of four elements: nihonium, moscovium, tennessine, and oganesson, right? So this is, and coming to the point which I was trying to tell you, that why it is important for us to write the correct configuration of elements in terms of orbitals. This is referred as, just as a layman, I request you to just bear it for till the next class, that this is known as S block. With reason I'll explain to you, believe me. This is referred as D block. This is referred as P block, and this one is called as F block, right? So the moment, as you can see, as I told you, that cobalt is here, 27. If I write 3D7 at the end, only then I will be able to understand that it is a D block element, because in the end I'm getting 3D7, right? And if I write 4s2 at the end, I will assume it to be the member of S block, right? So it is very important for us to know both of them. The importance of converting an orbital into orbit concept, we will take it up surely in the next class. So is the last point clear to all of you, that seventh period of modern periodic table is complete now? And what is the importance of writing the configuration in terms of orbital first and then converting it to orbit, right?
Yes,
Any
ma'am.
doubts? Okay, now I'm giving you one homework, that you will be doing the same thing with atomic number, I'll say 60. We'll do it for 60 and we will do it for 45. Write the configuration in terms of SPDF and then convert it into orbit. We'll be taking these two as example to study the features of modern periodic table. Right? Any query to anyone or any suggestion or whatever you want to say? Any query or question, Ritika?
No, ma'am.
Okay, so should we wind up the class?
Yes, ma'am.
Okay, thank you for being there, and we'll see you in the next class.
Thank you, ma'am.
Thank you, ma'am. Welcome.